Here I welcome you once again. This is the circuit that you are seeing in front of me is a temperature control circuit, and it is another project that I have done as my BTech project. It basically has a circuit with a controller, a display unit, a battery power source, and a heating glove. Now what happens is that the heating glove that you're seeing has carbon fibers inside it, and carbon fibers conduct electricity. Carbon fibers, when electricity passes through carbon fibers, it generates heat, resistive heating, that is. So this is utilized to keep the glove warm. Now simply passing current through the carbon fiber will make it heat as long as it doesn't reach saturation. What is required is an efficient control unit that can control the temperature and maintain a certain temperature that is required. So this circuit does precisely this purpose. The microcontroller that has been used is, you're seeing here, this chip is called ATmega8. It's a microcontroller from the AVR series of microcontrollers. It is this microcontroller that is doing the controlling activity, maintains the temperature. It has programs running in it. The microcontroller is connected to a display unit. As is obvious, without a display, things will look very vague and things won't make much sense. So in this display unit, you can see that the reading over here is the set temperature. Set temperature means the temperature that is required, that is set by the user, that the user wants. And the reading over here is the temperature that the temperature sensor measures at a certain instant of time. Now this temperature sensor is located inside the glove. I can't show you, it's located inside the glove where the heating elements are placed, so that the sensor reads the temperature of the heating element and sends that data to the microcontroller, and based on several things, it's a closed loop feedback control system based on the temperature that is required and the temperature that is current. PWM pulses are sent to the microcontroller through these power transistors, and that is what maintains the temperature. Now what I'm going to do right now are, as you can see, these two switches. What they do is, when I press this switch on the left, as you can see, is observe the reading on the right. Now one thing I forgot to tell you is that both these readings are in degrees Celsius, as might be obvious to people observing this, but just for saying. Now when I press this button, it increases the temperature, set temperature here, and when I press this button, it decreases the set temperature. Okay, so that's what I'm going to do now. Let me set a certain temperature. See, when I press this button, I can increase the temperature 35, 36, 37, 38, 39 to whatever I want, 40 degrees Celsius. When I press this button, it basically decreases the set temperature that I want. Alright, so let me now set a temperature that is somewhere above 40, just for demonstration's sake. Okay, let's keep it at 44, and this is the current temperature. The temperature that is inside the glove is 34, 35 degrees Celsius, somewhere there. It is slowly going to reach this temperature, and once it reaches the temperature, it is going to approximately stay at that temperature, and that is exactly the whole purpose of the circuit, to maintain a certain temperature that is required by the user. So the user now wants 44 degrees Celsius, and the temperature that is inside the glove is 34 degrees. Slowly it will rise, and I'll stop blabbering for some time and make you concentrate on the readings of the LCD. As you can see, the temperature is slowly rising. one point is that there's, since the circuit has been made on breadboard, there's lots of noise on the line of the sensor, and although there have been some decoupling, noise decoupling capacitors that have been kept, but still lots of noise. Well, there is some reason the BD33C IC, which rarely heated up before, as heating, but that's not a cause of concern. There's plenty of current that passes through this, and slowly you should see a rise in temperature. It takes some time for the temperature to rise, somewhere between 3 to 5 minutes. Right now it's stuck at 36. Okay, now as you can see, it moved to 37, 36, 37, 35. It will require some patience to observe this change happening. I admit the change is pretty slow, but the change is there definitely. I have no idea why it's still not showing. This probably the sensor is not located correctly. Where is it? It's not. Where's the sensor? Where's the sensor? Stop this video here.